Good evening and welcome to the Historic Wayne Theater Ross Performing Arts Center. My name's Tracy Straight. I have the privilege of being the executive director here, and on behalf of our board of directors, our staff, and our awesome ambassadors, those are our treasured volunteers, we thank you for joining us for our Science Speaker Series. We are so thrilled to be connected with the Virginia Natural History Museum, who bring us wonderful speakers, and we're looking forward to them being more a part of our community very, very soon. I hope you were able to check out what is coming here at the Wayne this month. And on Friday night, we'll be showing our Super Happy Awesome News. It's our children's virtual musical on the big screen, or you can get a link on demand. And so much more. At the end of the month, we will be the world premiere for Deep into the Darkness on Halloween weekend, which is a play of Edgar Allan Poe's works. So we are very excited about that and have a costume contest to come. We are also offering events here at the Wayne Theater, live in person with socially distanced seating and hybrid style events. So please look at our website of everything we have coming up, and we thank you for being here. And I'm going to turn it to the executive director, Joe Kuiper.
Okay, good evening, everybody. So it's great to be back at the Wayne Theater, and we're not just at the Wayne Theater, but we are broadcasting live on Facebook through the Wayne Theater's website, or I should say Facebook page, as well as that of the Virginia Museum of Natural History. So if you're tuning in, thank you so much for coming out and supporting us. So some of you may have seen my talk last month, and what I did here at the Wayne Theater was to give an overview of where we stand with our project. That is to put a branch of the Virginia Museum of Natural History right here in downtown Waynesboro, adjacent to Constitution Park. And so, as everybody knows, COVID has slowed everything down. This is a capital project, and all capital projects are on pause. However, we are in the budget for the state of Virginia to move forward with what we call our detailed planning, which is an 18-month kind of regimented process that all state capital projects go through. So we stand ready to conduct that work here very soon. And this is one image of what you might be seeing. This is part of our pre-planning study. This is not necessarily the final design, but this is the front of the building as it faces Constitution Park and the South River. So we're really excited to have gotten to this point, even more excited to move on to detailed planning. So in that talk, I walked people through the galleries, the various exhibit themes on the 2 floors of this museum. And it was an exciting process to come up with the storyline. And what makes it even better, in my estimation anyway, is that this is all place-based. We interpret Virginia's natural heritage in a global context, but all the stories that we're going to be telling within these galleries here are going to be tied right here to the Blue Ridge and the Shenandoah Valley and the areas within very easy drive of downtown Waynesboro. So I just think that's really neat. I just love that idea, and the idea that we're going to blend our exhibit experience directly with Constitution Park. So if you visit the museum, you take a short walk outside down to the South River. As you've all probably heard, there's going to be the renovation and expansion of Constitution Park and its amenities. So you can learn a lot about natural history in the galleries and take that and apply it practically outdoors, or even go up to the Shenandoah National Park and do the same thing, or vice versa. You can come from either of the parks and take what you've observed and interpret it in those galleries. So we think it's going to be a really unique experience and something that I would anticipate would be emulated in other areas down the line. So what we're going to do tonight is I have with me Dr. Adam Pritchard. He is our assistant curator of paleontology. He's a vertebrate paleontologist, so he studies animals versus, say, plants and other kinds of organisms. And he came to us a little over a year ago from the Smithsonian Institution, where he was studying fossil reptiles. And we're just very privileged to have him and his talent and enthusiasm here at the museum. So without further ado, let's bring him up, and please give a warm welcome to Dr. Adam Pritchard.
There we go. Oh, thank you. I haven't even said anything yet. Okay. Well, I guess I have now. There we go. Just had to get to the right slide. Cool. Alrighty, well thanks Dr. Kuiper for that introduction, and thanks everyone for tuning in either here at the theater or in the comfort of your own home, and I hope I'm able to spin some good yarns about the fossil record of Virginia and specifically that in and around the Shenandoah Valley. The Virginia fossil record is a really important one. This is an engraving of a fossil shell, a scallop, that was made in the 1600s. It was published by a naturalist named Martin Lister, and it's quite significant in that it is the oldest known illustration of a North American fossil from modern scientific texts, and it's specifically an example of what's called Chesapeake jeffersonius, which is actually the state fossil of Virginia. And it's almost certain that this specific specimen, the first specimen ever illustrated from North America, is a Virginian. Over 100 years later, Thomas Jefferson, before he was president in 1797, publishes on a series of toe and claw bones from an ancient mammal, again discovered in Virginia, that he considered to belong to some kind of large carnivore, like some kind of giant lion. The reality was quite a bit different. These bones actually turned out to belong to a giant ground sloth. It's an amazing thing that used to exist, and that was actually named Megalonyx jeffersonii. And both of these are examples of just some of the first major kind of discoveries and the recognition of fossils in the North American continent. And both are Virginian. But since that time, at the turn of the 19th century, American paleontology has really just ballooned, and every single state in the Union has its own unique fossil record that is represented today in museums around the country and the world. And quite often, the fossils that we see in major museums are ones like this. They're big, impressive skeletons of things like dinosaurs, and quite a lot of those come from the American West. And so that's what a lot of the most traditionally impressive fossils look like. So we have this sort of forest of knowledge that comes out of all of the US states of the fossil record and how that fits into our history of the planet. But the reality is it can be easy to miss the trees for the forest, because each state has its own unique stories to tell. And it's something that I really appreciate about the mission of our museum, the Virginia Museum of Natural History. We focus on sort of the trees that exist in the Virginia fossil record and how they fit into the broader forest, as Dr. Kuiper was talking about. So although when you walk into the main hall, the first things you might see is the skeletons of large dinosaurs like this Allosaurus, which again come from the American West. That's sort of the grabber. That pulls you in. But then when you start to walk through the exhibit, Uncovering Virginia, which describes the full history of complex life on our planet, that is done within the context of the Virginian fossil record. Over 500 million years of discoveries from Virginia that are used as waypoints to understand the complexities of life on our planet, from the most ancient undersea ecosystems, where we first get complex life, to the arrival of humans in the Commonwealth just a few tens of thousands of years ago. And I love this approach to natural history because it emphasizes how the fossil record is it's not something far away, it is close to us. And that fits and contributes to the broader story of Earth. One of the things that excites me about Virginia's fossil record is this, and this is a map that you see when you first walk into Uncovering Virginia. And I'll zoom in on this map. Our exhibit in Martinsville really concentrates on 6 primary fossil localities. And the space for the exhibit, that's about all you can fit comfortably without, really not telling those stories particularly well. However, as natives of this particular area, you might notice that, the Shenandoah Valley is kind of not really represented by our exhibit there. Is that a consequence of there not being fossils? Well, no. There are amazing fossil stories to tell in and around the Shenandoah Valley over the past 500 million years. And that's what I'm going to be talking about primarily tonight. And I definitely think that's part of the reason that the VMNH Waynesboro is an amazing opportunity, because this new facility will provide us with the space to teach people about the whole fossil history of Earth, but by concentrating on those sort of waypoints that the Shenandoah Valley offers and in the surrounding area. And the Shenandoah fossil stories I'll kind of be highlighting tonight extend from the early reef ecosystems from over 500 million years ago, where complex animal life first appears in the fossil record, to the age of reptiles and the dominance of dinosaurs on the landscape, and then finally to the age of mammals over the past 66 million years, culminating in the Ice Age of just the past million years, which for paleontologists, that actually is just not much time at all. To give you a sense of just kind of the whole history of complex life on our planet, here's a brief kind of overview of the time periods with their ridiculous complex names and all of the sort of time intervals represented in millions of years right across the top. So in the Shenandoah Valley, we're going to open between 540 and about 350 million years ago, where we have these ancient reef ecosystems. And then we'll skip 100 million years because that's just not preserved in our record. Then we'll reach the age of reptiles beginning around 250 million years ago, where we'll get some classics like the dinosaurs. And then a large rock from space hits the Earth and wipes all of those out about 66 million years ago. And then finally, we'll pick up in the Shenandoah again in the age of mammals and the Ice Age. So these three episodes will be our sort of focus for tonight, and I see them as sort of keystone ideas for the exhibits in Waynesboro in the coming years. So it's quite remarkable, but the Shenandoah Valley, in many ways, is built on top of ancient reefs that were underwater between 540 and 350 million years ago. And during this time, the seafloor was sort of the hotbed of life on our planet. This representation of it comes from a diorama that's at the National Museum of Natural History, the Smithsonian Museum in Washington, D.C. And I've always loved this because it shows some of the most bizarre organisms that were around at that time, and some that are a little bit more familiar. And this was a time when, at the beginning at least, for the first 100 or so million years, where complex animal life was restricted to the oceans, and indeed largely restricted to sort of the sea bottom. There were only a few groups of animals that were actively swimming or drifting in the water column. Pretty much everything was just sort of right there down on the sea floor. And it's only at the very end of this period, between like 400 and 300 million years ago, where you start to see the emergence of active swimming animals that rise up from the seabed and are just spread throughout the water column. This is called the Nekton Revolution. Nekton refers to these active swimming animals. And at this point, the beginning of this period, 540 million years ago, this is Earth, oddly enough. Virginia is about where that star is, mostly underwater, right alongside a landmass that will eventually become North America. So pretty much all the land of the Shenandoah Valley is represented there, and it's completely underneath the ocean. So sediments are being laid down on these ancient reefs during this time period. So the valley and the ridges along it are actually made up of rocks that were laid down between 540 and about 350 million years ago. The rocks from later in that time interval are a little bit less common just because they've largely weathered away, but there's an amazing record of this time period from throughout the Shenandoah Valley. And if we look at just kind of the spread of fossil sites across this area, we can see that pretty much the entire valley is represented in terms of places where fossils from these ancient marine ecosystems are discovered. Many are still represented by road cuts that you'll drive past on the highway, disused quarries. They're just rock faces in parklands throughout the entire region. Like this one is in Frederick County. I think that's in Frederick County as well. That is a rock outcrop in Rockingham. And what I want to do is kind of highlight some of the Virginia fossils that we have from these ancient reef organisms and just kind of describe the weirdness and the familiarity that existed at that time. One of the most iconic organisms from the Virginia sea floor is the trilobites. These are animals that are closely related to modern-day arthropods. So things like crustaceans and insects, these are distant relatives of those that occupied the seabed from between 540 and about 250 million years ago. So for a good half of this time period, you see these weird-looking pill bug-like animals just sort of walking around on the sea floor. These bottom feeders ranged in size from near microscopic animals all the way up to the size of a skateboard. And all across the Shenandoah Valley, we have records of trilobites. There are dozens of species represented in the collections of the Smithsonian and the Virginia Museum of Natural History. Some of the oldest ones look kind of like this. It's tough to see, but there's sort of impressions of the broad head regions in these animals, in this creature called Olanellus. See a penny down there. So these were not particularly large animals represented in Virginia. We have some that are beautiful, three-dimensionally preserved, the entire bodies of these animals preserved from other fossil deposits in Virginia, and some actually reflect the ancient behaviors of these trilobites. This one, for example, is entirely curled up on itself with its entire body sort of enveloped in a little ball. And that defensive posture is something that's reflected in some of the modern relatives of trilobites, like these isopods, or as I know them, roly-polies, a phrase I never thought I would utter, in a professional talk, but there you go. So we see in these animals not only this variety of things like trilobites, but also just sort of a little reflection of what they were like in these ancient Shenandoah reefs. We also have sort of the reef builders themselves, which changed through time throughout this interval. So we see ancient relatives of the modern-day corals, which rise through time, but also ancient animals called bryozoans, which built some of the reefs very early in the time of the Shenandoah. And you'll note in the middle that our trilobite, there's a trilobite there that's in somewhat serious trouble thanks to some of the creatures at the top of the food chain during the time of these Shenandoah reefs. And those are the cephalopods. So this is the group to which belong squid, octopus, cuttlefish. And during the time of the Shenandoah reef, cephalopods were quite often the top predators in these environments. And some of the first animals to adopt and a sort of active swimming as a way of getting around. Many of them had these long cone-shaped shells called orthocones, and these animals could reach the size of your average pickup truck. So these were enormous predators, but not really in the Virginia fossil record. Although we have a lot of these cone-shaped shelled cephalopods, none of them quite get that big. These are just about a foot long or so. As time goes on, though, in the time of the Shenandoah reefs, we see changes in the shapes of these cephalopods. Some retain that cone shape, but others start to develop these beautiful, almost coiled shapes to their shells. And these actually have internal chambers, which likely help these animals maintain buoyancy and sort of float passively in the water column. And as we go later and later in time, the coils become tighter and more complex. So we see sort of this increasing complexity of these shelled cephalopods that would have allowed them to sort of occupy different regions, different kind of latitudes within the ocean during this time. And that ties into our broad idea of this nekton revolution, where as time goes on during the era of the Shenandoah reefs, animals in many different groups start to rise in the water column and become more active, moving swimmers. The next monster I want to highlight from the Shenandoah reef ecosystem actually wasn't in the original diorama, so I've superimposed it here. And if you can actually see a difference between the prior images and this one, you get a gold star. But it's hard to see because it's pretty tiny, so I'll zoom in on this one. So this weird worm-like animal is a conodont. And their jaws, the bones or the structures that made up their jaws, were some of the most plentiful fossils from these Shenandoah reef environments. But as we zoomed in on this one, you might be able to guess that they're pretty tiny. Here's a slide from the collections of the Virginia Museum. You can see the penny up there for scale. And those tiny, tiny little structures you can see in there, I'll zoom in a little bit more, are the pieces we have of these ancient conodonts. These actually are, these complex structures make up the jaw apparatus of these ancient worm-like animals. They're actually closely related to the earliest fishes. And the way they're arranged is known from a few exceptional fossils that show the preservation of the animal and the arrangement, the position of these tiny little jaw elements in the mouth. And if we look at that conodont, we take a look at its face. I warn you, this image may haunt your nightmares in the future. They're arranged in just this exceptionally bizarre way that look nothing like the jaws of other vertebrate animals. And so conodonts, although exceptionally tiny, had this incredibly complicated and varied jaw apparatus that had little tooth plates arranged in various different places. And some scientists have actually gone as far as to try and see exactly how those elements would move independent of each other, looking basically down the mouth of a conodont here. And it's just such an alien mechanism for biting in these creatures. But their jaw elements, like the ones illustrated here, are present across the world and indeed the Shenandoah Valley. And differences in the conodont jaw bits from different locations around the world actually allow us to sort of correlate time periods across huge spans of geography. To give you a sense of how big these are, those scale bars are actually far less than like 1/10 of a millimeter. So that tiny, tiny, tiny elements, but that can tell us a great deal about the biology and sort of the geography of these ancient animals. And conodonts, much like those cephalopods, were early adopters of sort of an active swimming lifestyle. Although they weren't particularly large, they definitely were active swimmers. But late in the time of the Shenandoah reefs, we start to see some animals that are recognizably fishes, although they're still really, really strange. The best record we have belongs to an animal that looks like this. This is a creature called Bothrialepis, which is an early fish that is represented by fossils around the planet. So at the front, you can see it's got these two little eyes that are actually positioned on top of its head. Those crab claw-looking arms are actually its forefins. Incredibly strange animal whose body is basically built out of bony armor, but sort of a pioneer in terms of just being a large-bodied fish in the world. As I said, Bothrialepis are known from around the planet, and we have skeletons of different qualities in fossil sites around the world. This one, for example, comes from Canada. But a little bit closer to home in Frederick County, there's a fossil site along the highway that preserves rocks of the appropriate age. And although the fossils aren't quite as beautiful as that specimen from Canada, we have examples of Bothrialepis from this site, and they're distinct enough that we can say that this is a separate species, which was dubbed Bothrialepis virginiensis. So from the Virginian fossil record, we increased the diversity of this earliest real active swimmer. We have additional specimens of that weird head shield, little cavity that actually supports where the little eyes go from the Virginia Museum collections. So Virginia's fossil record adds this interesting wrinkle, this important development to the record of Bothrialepis, and thus the whole story of fishes and this nekton revolution. Our record from the Shenandoah Valley represents an important contribution to this story of how ocean ecosystems literally sort of rose up and adopted a more sort of modern distribution of organisms over a period of 200 million years. And about 350 million years ago, the deposition of this ocean sediments in the Shenandoah Valley comes to an end. And we move on to a period over the next 100 million years, which are sort of a blank in the fossil record of the Shenandoah Valley, because the geology of Virginia takes a big turn. So we began with Virginia underwater, and it remains so for that first 200 million years of this period. But the world changed over that time. The continents started to move rather radically to the point where they coalesced, and Virginia goes from being an underwater kingdom to being this sort of landlocked area in the middle of the legendary supercontinent of Pangaea. A lot of that starts happening. The rock that was present with these Shenandoah reefs starts to rise out of the ground, and a large landmass begins to converge on what will become the Atlantic coast. And that landmass is actually what will be the continent of Africa. These forces continue. the former reefs rise out of the water, the future African continent encroaches, and the ocean that once existed to support those Shenandoah reefs begins to shrink. And that process continues to the point where those two continents have fully crashed together and there is no ocean between them. In fact, if you look at a map of Pangaea, there's not a lot of ocean between many of what will be the continents. They're sort of glommed together into this mass. And to me, this period in time, which Pangaea begins around 250 million years ago, is the most interesting time in Earth's history. I'm biased because I study it all the time. It's a period of great transition. In the Shenandoah story, we shift out of these reef environments to the time of the Triassic period and brings us to the most famous fossil animals of them all, the dinosaurs, which rise to prominence during this time. And I must admit, I cheated a little bit here, so you'll see later. We don't have fossils exactly from this interval within the Shenandoah Valley, but if you travel just over the Blue Ridge to the east, there is a lot of interesting stories to tell about this Triassic period. One of the things that's really interesting about it is that dinosaurs are not alone in this time. They are not the only major group of land animals. In fact, for much of the Triassic period, dinosaurs are a minor component of land environments. The only dinosaur, despite, there are a lot of big, impressive-looking reptiles here, but the only dinosaur in this image is that two-legged predator that's walking in the background. And I really like this because it kind of reflects what the Triassic fossil record looks like on land. You get a lot of big reptiles, many of which are related to modern-day crocodiles, some of which are herbivores, some of which are predators, and very, very few dinosaurs during this time. And it's easy to anthropomorphize a little too much, but it's hard not to see dinosaurs like the ones in the foreground here, these sort of fleet-footed, skinny, fast-running animals in a world of other bulky carnivores and herbivores is sort of an underdog story. During most of the Triassic, they are small, they are severely outnumbered, and they're just not particularly abundant in the fossil record. But once you reach the end of the Triassic period, dinosaurs basically just outcompete everybody else and become this dominant feature on the landscape. And the fact that we have a record of this time in Virginia is thanks to an important geological event. So I talked about how Pangaea all comes together, and about 230 million years ago, it starts to come apart again. So the plates that make up the Atlantic coast of North America and North Africa start to shift course and begin to separate from one another. And the space created between them inundates to form the very young version of the Atlantic Ocean. If we zoom in on that map where the Atlantic is just beginning to form between what will be the Atlantic coast and what will be Morocco, we can see that not only is there this thin strip of Atlantic Ocean, but there are a series of large lakes that form right alongside that, just to the west of the young Atlantic. And these lake basins, which form as a result of this massive rifting that's occurring between North America and Africa, are critically important for this fossil record because across the eastern seaboard, these lakes deposited tons and tons of sediment which preserved a record of life from the Triassic. In Virginia, we are lucky enough to have a lot of separate little basins that tell us about life during the early part of the age of dinosaurs. And as I said, the Shenandoah Valley itself doesn't preserve any of these Triassic basins, but if you hop over the Blue Ridge to Culpeper, Virginia, you'll find one of the most substantial, the Culpeper Basin. The basin actually outcrops all around the town of Culpeper, but the best exposures come from this site. This is a place called the Luckstone Quarry, which preserves an interval around 215 million years ago. So this is during that time where dinosaurs in most places in the world are not a major part of the landscape. And the mudstones of the Luckstone Quarry, it's just complicated to say, preserve just an abundance of evidence of life from this time. So we have Lots of fossils of complete fishes. They're a little tough to see here, but all of those shiny little bits are these incredibly kind of beautiful bony scales that covered the fishes from this time. And also a lot of teeth and little bits from some of the large crocodile-looking predators there called phytosaurs, which were a major part of Triassic environments. But what really makes the Luckstone Quarry and the record from the Culpeper unique is that, unfortunately, well, this doesn't make it unique, because now I'm gonna disappoint everybody, because the Culpeper record, and indeed the entire fossil record of Virginia, has produced absolutely no dinosaur bones, ever. And it doesn't bother me. That's fine. I'm totally okay with it. It's not like a mission in my life. It doesn't bother me that Maryland and North Carolina both have dinosaur bones, but Virginia, for some reason, hasn't happened yet. Okay, yeah, it's a goal in my life to find the first dinosaur bones in Virginia. That will happen. But the Culpeper fossils are really important because, although they don't preserve dinosaur bones, that doesn't mean they weren't here. Their tracks are present throughout the Luckstone Quarry. This is a three-toed impression of a carnivorous dinosaur track. Here's some more three-toed impressions of dinosaur striding. There are some more still in the floor of the quarry. At this point, over 1,000 dinosaur tracks have been noted from the site, and many of them are almost certainly still present underground. It's hard to fully excavate these tracks because they're embedded in extremely hard mudstones. To get them all out would require rock sawing a ton of sediment, so a lot of them remain in the ground. But fortunately, there's been a lot of work done, particularly by paleontologist Rob Weems, who's one of the experts on Virginia fossils, in understanding these Triassic fossils of dinosaur tracks from Virginia and what they can tell us. And one of the things they can tell us is about the variety of dinosaurs that existed at this time. If you compare them with the skeletons of dinosaurs elsewhere, we have evidence of very large predatory dinosaurs, animals that are minivan-sized or more, that probably look something like this Dilophosaurus in the upper left-hand corner. We have some early herbivorous dinosaurs, the older members of the long-necked dinosaur family that will give rise to Brontosaurus and Brachiosaurus, which were actually kind of bizarre-shaped and walked around on their hind legs on occasion, including in the fossils from the Culpeper. And then a host of smaller carnivorous dinosaurs, too, from wolf-sized animals down to rabbit-sized animals. These reconstructions are not based on the tracks, but on more complete fossils from elsewhere in the world. So it really requires sort of a correlation of the shape of these footprints and the fossil record, the skeletal fossil record from other places, to fully understand what we have represented in Virginia. The tracks can tell us a lot more than just the variety of animals that were present. They can tell us a great deal about what exactly those animals were doing in their ancient environments. One can get a better sense of posture. And although the Culpeper tracks are mostly animals walking around on their hind legs, bipeds, some of the examples of three-toed tracks actually have little pads just in front of them. Very, very consistent in shape. And some of them with actually skin impressions that show that, this uncomfortable-looking sitting posture might have been something that was actually present for carnivorous dinosaurs. And it's not something we would predict based on the skeletons alone. But with the track record, we can actually have a sense for how these animals stood or sat in their day-to-day lives. And they can also give us a sense of just sort of what the stride of a dinosaur looked like. And thanks to that, we can get at least estimates for the speeds of some of these animals. And although most of them were just kind of walking around relatively slowly on a muddy bank, some of the Culpeper tracks suggest animals moving at roughly 22 miles an hour. So not the fastest critters in the world compared to what we have today, but it's a fair bit faster than I can go. And so while dinosaur bones are unfortunately still elusive, which is fine, from Virginia, we do have an extraordinary record of dinosaurs from our state and from just beyond the Blue Ridge that tells us a lot, not only about the variety of dinosaurs that were present in this time, but also about how they moved in their ancient environments. And after the Triassic period comes the Jurassic and the Cretaceous and all of the legendary dinosaurs, stegosaurs and triceratops, tyrannosaurs, and we also don't have fossils of those. Those are actually almost entirely from the American West, and unfortunately, much of the eastern seaboard, much of the remainder of that 165 million years of dinosaur dominance is absent. And then 66 million years ago, a giant rock from space hits the Earth, and dinosaurs have a really bad day that puts an end to their sort of dominion over the Earth. Which was good for us, because at that point, the small furry animals that sort of nipped at the ankles of dinosaurs began to rise to prominence, and the age of mammals really got going about 66 million years ago. And the Virginia fossil record, at least on the eastern seaboard, is pretty extraordinary from the age of mammals. Now, a lot of it, again, much like those ancient reef ecosystems, comes from marine environments. But these, instead of showing like vast coral reefs, attest to the presence of large marine mammals, things like whales, and the legendary giant shark Megalodon, which are kind of the poster children of the Virginia age of mammals record. And if you asked me a few months ago, I would say that after the time of these aquatic records, I'd say the only good locality in the state for later mammals, those of the Ice Age and beyond, was a site at Saltville, Virginia, in the far southwest. This was during the depths of the Ice Age, between 17 and about 12,000 years ago. Glaciers extended down through, all the way down through what is now New York to Pennsylvania, and Virginia, based on the record from Saltville, played host to elephants, giant sloths, many species of moose and deer, and even muskox. So, pretty extraordinary record of these Ice Age animals. And again, then, fortunately, that kind of left the Shenandoah pretty empty, or so come back. There we go. Left the Shenandoah relatively empty, which is kind of disappointing, but just about a month ago, I was presented with this specimen on the left by a reverend and fossil collector who was in Rockingham County. And he was curious if this specimen would have come from the local area. This is a tooth, a very large tooth, belonging to an animal that looks like this. This is the skull of a mastodon, an ancient relative of elephants that was a really big feature of American ecosystems for about the past 10 million years, disappearing only during the last Ice Age about 11,000 years ago. And so he had obtained the specimen secondhand and was curious if like Rockingham County made sense as the original locality, because that's what he had been told. So I was really curious, so I began researching sort of other Ice Age mammal discoveries in Virginia, and I learned something amazing about the Shenandoah Valley. So all the rocks here, by and large, are very, very old. They were deposited during the times of those ancient reefs. So I was thinking that a lot of the fossils just had to come from that time. But the reality is that a lot of those rocks have been eroding for a very, very long time as well. And there are vast caves and caverns from across this region. This is a photo from Luray Caverns, and quite interestingly, there's records of mammoth teeth coming out of these. So the fossils of, or the ancient remains of animals that were present in the Ice Age were preserved in these caves. And looking through the scientific literature, I discovered that there were a lot of localities across the Shenandoah Valley and surrounding areas that produced the fossils of Ice Age animals. This is along the Cow Pasture River up to the left. There's the National Chimneys in the center, and the hot springs of Bath County on the right. And although these rocks were laid down a long, long time ago, the caves that have formed within them have produced a huge range of Ice Age fossils that gives us a great sense of what life existed during those times in the Shenandoah Valley. And again, much like the record of those ancient reef ecosystems, when you really look into it, there is an amazing variety of fossil sites, mostly from these caves and ancient deposits that contained Ice Age animals. I'm actually really excited because a lot of these have only been sort of recorded in the registers of the Smithsonian Museum in Washington, D.C. So once that opens back up, I'm really excited to go in and see what is actually preserved of these mammals from Virginia. But the records that we do have established include a range of classic Ice Age animals. So probably the most famous is the legendary woolly mammoth. But in addition to that, we have records of ancient tapirs. I mentioned very early on the giant ground sloths. There's a lot of fossils of those that come out of Virginia. This other standing animal is the giant short-faced bear, which was a huge predatory animal with a ridiculously small head. But even though it looked ridiculous, it had a much more carnivorous diet based on its jaws and other records than today's grizzly bears. And some more modern-looking animals as well. There's a reindeer skeleton, and then muskox. And it's not just giants that are represented in the the Shenandoah Ice Age record. So these right here are an arrangement of tiny little jaws, the largest being just over an inch long, from shrews discovered at the Natural Chimneys site. And some of these formed not because animals fell into these caves and died, but others were likely left by the predators that ate them, things like owls and raptors, which left huge piles of their prey animals behind. And there's an arrangement of fossil bones from a similar fossil site that we have from the Virginia Museum of Natural History. You can see my tweezers moving them around. There's just an amazing record of these small animals from some of these sites. Bats, frogs, snakes, rodents, and all of these little small bones of vertebrate animals, which are called microvertebrate sites, just give us a sense of what life was like at just about every scale during these ancient intervals. And the story these Ice Age fossils in the Shenandoah Valley show us is pretty clear. A lot of members of the Ice Age ecosystem did disappear at the end of this time when the climate was warming and changing and humans arrived in the environment. But others, like muskox and reindeer, really started to shift their ranges relative to where they were during the Ice Age. So here the glaciers are covering much of northern North America, and then in modern day, things have shifted substantially further towards the Arctic. So as we learn more about the diversity of Ice Age animals and the ranges they had, we can really make better predictions, not only about what life was like during these ancient times, but also about how animals respond to big changes in their environments and their climates, and sort of what those responses look like. So I'm happy to conclude with just saying that the rocks of in and around the Shenandoah Valley preserve an amazing record of life over the past 500 million years, extending from the ancient reef ecosystems that form the floor of the valley and many of the mountains, to the emergence of land environments in Virginia and the rise of reptiles, and finally to the age of mammals culminating in the Ice Age just a few tens of thousands of years ago. So, excitingly, we can take this map of stories that the Virginia Museum of Natural History tells today and add some new complexity, some new species, and some new sites in and around the valley that will really expand the stories that the Virginia Museum of Natural History is telling with more of life on our planet. And it's going to be really exciting in the coming years to tell these stories through the VMNH Waynesboro campus. And, actually, I'm really excited to get out there and try and find some more Shenandoah Valley fossil sites, because I really feel like we've only just begun to really understand the breadth of stories that we can tell using the fossil record of Virginia. And I'm grateful to have the opportunity to speak with you this evening, and I'd be happy to take any questions if you have any. Yes.
What is it?
A gizzard stone is a structure that quite often, I'm trying to think how best to say it. So a lot of modern birds and some reptiles have a special structure in their gut tube called a gizzard. And this basically acts as a little collecting chamber, in some cases for stones that these animals eat, that help them take food. So they take it in, goes into this gizzard, And thanks to the stones and the musculature of the gizzard, it helps grind that up and make it, digestible. Because in the case of, say, a bird, it doesn't have much of a processing mechanism like a chewing mechanism in its mouth, so it needs some kind of assistance to make that happen. In the fossil record, we see evidence that a lot of dinosaurs, despite having teeth, also didn't have a complex chewing mechanism, so that we find these sort of similar stones in their gut regions as well. In the fossil record, they are often recovered, but I mean, they still exist today. Chickens, I just saw a presentation actually from a scientist that talked about, experimental experiments in which chickens swallowed different kinds of stones. So birds are still doing it every day.
Hi. I was at the Saltville Museum maybe 15 years ago. I thought it was really interesting, but I remember they were very unhappy that all their, what was it, mastodons or woolly mammoths, all the skeletons that had been found in that Saltville area had gone to the Smithsonian, except I think they had one there maybe. Do you know if they're trying to get those back from the Smithsonian, and are you guys trying to get some of those back from the Smithsonian?
It's not something I'm actively working on right now. I actually wasn't aware of any. I know that one thing that's interesting about Saltville is sort of the collecting areas for the major findings from those sites have shifted multiple times, from the museum in Washington to the VMNH to now the primary workers out there from Eastern Tennessee State University. But it's not something I'm actively working on, but I definitely want to learn more about just how exactly that site operates and how they make those decisions.